In this section, we have trigonometric substitution. Here on this part, we have procedure for the trigonometric substitution. Step 1, write down substitution for x, calculate the differential dx, specify the selected values of theta for the substitution. So this is our first step. Then second step, substitute the trigonometric expression and the calculated differential into the integrand, and then simplify the results algebraically. Step 3, integrate the trigonometric integral, keeping in mind the restrictions on the angle theta for reversibility. Step 4, draw an appropriate reference triangle to reverse the substitution in the integration result and convert it back to the original variable x. So here on this part we have right triangles. The one that I have here on left side. So here our angle is theta, and we have this side as a, this side is x, and we have hypotenuse is the square root of a squared plus x squared. When we have this, we're going to use x equal to a times tangent theta, and our square root of a squared plus x squared, that is equal to a times absolute value of secant theta. Then this one that we have here, hypotenuse is a, this side is x, and this side is square root of a squared minus x squared. So in this case, we're going to use x equal to a times sine theta. And square root of a squared minus x squared is equal to a times absolute value of cosine theta. And the last one that we have here on the right side, hypotenuse, so this side, this part, hypotenuse is x. This side is square root of x squared minus a squared, and this side is a. When we have this right triangle, we're going to have x equal to a times secant theta. In this case, square root of x squared minus a squared, that is equal to a times absolute value of tangent theta. So these are reference triangles for the three basic substitutions. I find the sides labeled x and a for each substitution. Example 1, evaluate integral. Here we have negative 2 times square root of 3 to positive 2 square root of 3, and this is for dx divided by 4 plus x squared. So on this part, based on what we have in denominator, 4 plus x squared, this is the same as the right triangle that we had. Hypotenuse was square root of a squared plus x squared. In that case, x is equal to a times tangent theta. What is given is 4 plus x squared, so that is equal to 2 squared plus x squared. So what I have here, this one is a, so a is equal to 2. So this means we're going to use substitution x equal to a times tangent, and a is 2 because of what I have here. So x is equal to 2 times tangent theta. So in this part we have x squared. Use x equal to 2 times tangent theta and find x squared. So x squared is equal to 4 times tangent squared. And then we have to find the derivative of what we have here for x. Recall that derivative of tangent with respect to theta, that is equal to secant squared theta times theta prime. So based on that, dx is equal to 2 times, so derivative of tangent is secant squared theta times d theta. Note that when we have x equal to 2 times square root of 3, theta is equal to pi over 3, because here we have 2 times square root of 3 equal to 2 times tangent theta, and based on that, tangent theta is equal to 2 times square root of 3 divided by 2. So tangent theta equal to square root of 3. When tangent theta is equal to square root of 3, that is when theta is pi over 3, because tangent pi over 3 is equal to square root of 3. And here we have negative 2 times square root of 3 equal to 2 times tangent theta. So when we have x equal to negative 2 times square root of 3, theta is negative pi over 3. And that is because tangent negative pi over 3 is equal to negative square root of 3. So based on that, theta is negative pi over 3. So this means when we try to integrate dx over 4 plus x squared, and this is from negative 2 square root of 3 to positive 2 square root of 3, that is equal to, now instead of x here we have theta. So what we have for dx is 2 times secant square theta d theta on top in numerator, so on this part. And in denominator we have 4 plus x squared, and x squared is equal to 4 tangent squared. And in this case, instead of negative 2 square root of 3 and positive 2 square root of 3, now we have to use what we have for theta. And for theta we have negative pi over 3 and we have pi over 3. So next step here on this part, we have to integrate 2 times secant squared theta d theta divided by I factor out 4. So in denominator we have 4 times 1 plus tangent squared, and then simplify. What we have here is 2 divided by 4, so that is 1 over 2, and I have that outside of integral. So next step is equal to 1 over 2 times integral secant squared d theta divided by 1 plus tangent squared. And then instead of what we have here in denominator 1 plus tangent squared, that is equal to secant squared. So here rewriting all these, but here in denominator we have secant squared. Then next step here on this part, what I did is that I can cancel this part, secant squared divided by secant squared, so that part is 1 times what is left here is d theta. So here we have d theta. So here we have 1 over 2 integrate d theta. So that is equal to 1 over 2 times theta, and this is from negative pi over 3 to pi over 3. So that is equal to 1 over 2 times, using this part first instead of theta, so we have pi over 3 minus, use this instead of theta, negative pi over 3. So this part is 2 times pi over 3 multiplied by 1 over 2, cancel that part, the answer is pi over 3. So this is our final answer for this part. Evaluate the integral, integrate square root of 100 minus t squared times dt. So in this case we have square root of 100 minus t squared, and we're going to use what we had for this part, square root of a squared minus x squared. So in that case x is equal to 8 times sine theta. So based on this, what we have here on this part for a, this is 100, so that is 10 squared. So 10 squared minus t squared. So that means our a is 10, and instead of x we have t. So use the substitution t equal to 10 times sine theta. So using t, now we have to find dt, so derivative, that is equal to 10 times cosine theta d theta. And now find integral. This is equal to integral square root of 100 minus, instead of t, here I'm using 10 sine theta. So t squared is equal to 100 sine squared. And then here on this part, multiply by dt, and that is equal to 10 cosine theta d theta. And then next step, here factor out 100. So 100 times 1 minus sine squared, that is inside square root, and then multiply by 10 cosine theta d theta. So square root of 100 is 10, multiplied by square root of 1 minus sine squared times 10 cosine theta d theta, and then multiply these two. So we have 10 times 10 is 100. I move that outside of integral. So we have 100 times integral square root of 1 minus sine squared times cosine times d theta. Instead of 1 minus sine squared, I used cosine squared. So what we have here is equal to 100 integral square root of cosine squared times cosine times d theta. Next step, use the fact that cosine theta is greater than 0 when theta is between negative pi over 2 and pi over 2. So use this to simplify. So what we have here on this part, this is equal to 100 integral instead of square root of cosine squared. Now here we have absolute value of cosine multiplied by cosine times d theta. And then next step, so cosine theta is greater than 0 because of that. Instead of this part, now we have cosine times cosine is equal to cosine squared. And then we have to use the double angle identity to remove powers of cosine theta. So instead of cosine squared, I used 1 plus cosine 2 theta divided by 2. And then I simplified this part, so 100 divided by 2 is 50, multiplied by integral 1 times d theta, then plus, again, 100 divided by 2 is 50 times integral cosine 2 theta times d theta. Now integrate, so we have 50 times theta plus 50 divided by 2 times sine 2 theta plus c. So c is constant. Then next step, I simplified 50 divided by 2. Here we have 25. And then I use double angle identity sine 2 theta equal to 2 sine theta cosine theta to get an expression in terms of sine theta and cosine theta. So instead of this part that we have here, sine 2 theta, I use 2 sine theta cosine theta. So this is equal to 50 theta plus 25 times 2 times sine theta cosine theta plus constant. So here 25 times 2 is equal to 50. So here we have 50 theta plus 50 sine theta cosine theta plus c. And then using what we have here, so we had t equal to 10 sine theta. I use that one to find theta. So sine theta is equal to t over 10. Based on what we have here on this part, theta is equal to inverse sine t over 10. So use that here on this part. Instead of theta, we have inverse sine t over 10 plus 50 times sine theta is what we have here, t over 10. And now here we have cosine. So finding cosine, use sine squared plus cosine squared equal to 1 to express cosine in terms of t. So I used sine squared plus cosine squared equal to 1. Cosine squared is equal to 1 minus sine squared. So cosine theta is equal to square root of 1 minus sine squared. And sine is t over 10. So cosine is equal to square root of 1 minus t squared divided by 10 squared. So we have here inside, we have 1 minus t squared divided by 100. And then simplify that part. So we have 100 minus t squared divided by 100. This is inside square root. And then cosine is equal to square root of 100 minus t squared divided by, here in denominator, we have 100. So finding square root of 100 is equal to 10. So I use 10 in denominator. So I will use this one, this cosine, here on this part. So instead of cosine, we have square root of 100 minus t squared divided by 10. And then simplify that part. So this is equal to 50 times inverse sine t over 10 plus, so here we have 10 times 10, that is 100 in denominator. On top we have 50. So 50 divided by 100, so we're going to have 1 over 2 times t. That's how I got t over 2. Multiply square root of 100 minus t squared plus c. So this is our answer for this part.